All right, guys, let's go ahead and get into this section of notes here. So first things first, we are getting into a new unit. So if you have not already, make sure that you label a new page in your notes. So this is going to be Unit 10. And this is going to be about area and volume. Okay, area and volume. So make sure that you have that labeled. And then specifically for today, we're going through 10.1, and this is just going to be focused on area, or just area of different 2D shapes. Okay, date for this lesson is the 15th. Then objective for today is basically we just want to be able to find the area of any 2D shape that we see in a diagram or a picture that we're given here. Okay, usually we'd spend more time on this unit and kind of break these down into different sections where we can look at a few of the shapes in the first lesson and then a few of the shapes in the second lesson. But unfortunately, with the pace that we have to go to for this class and make sure that we get to Unit 11 by the end of the year, we do need to kind of cram all this into one lesson here. So we're just going to be looking at the area of all these shapes. A big piece of this lesson and this chapter is just going to be formulas. So I'm going to be giving you guys the formulas for all of these types of shapes. We might not get the chance to go through an example with each one individually, but at least you'll have the formula that you'll be able to use. Okay. So first off here, if I want to find the area of a parallelogram, okay, so a simple one to start. Okay, area of a parallelogram is simply this. I'm just going to say area equals, and it's just going to be the base times the height. Okay, and what I'm going to do is I'm going to put a box around that, underline it, circle it, whatever, but make sure that stands out in your notes because we're going to be writing down a bunch of different equations and formulas, and you want to make sure that you have them written down. Okay, and then example to go with this here, let's go ahead and draw a parallelogram. So if we're thinking back to Unit 7, remember that's just a shape with two pairs of parallel sides. Okay, rough sketch, but it'll work. And then I want the base and the height. So the base here can be either one of these sides that are parallel to each other. So for instance, we could say this is the base. And then the height is not necessarily going to be these other two sides. It is going to be the distance from one base to the other. So for example, this right here, we draw this down, always going to be a 90-degree angle right here. This would be our height. Okay, it should always be a straight line. It should always be perpendicular to each base. And this is what you want. You want one of the bases, they're going to be the same, so it doesn't matter which one you choose, times the height. And like I said, the only thing you got to pay attention to is make sure you don't use the height as one of these other sides. Okay? All right, next one here, area of a triangle. Make sure we have this one here as well. We've already talked about this before, but just as a reminder, area of a triangle is going to be base times height divided by 2. Okay, area of a triangle is always base times height divided by 2. Try to draw that again. Okay, and notice it's just taking a parallelogram or a four-sided shape usually and just cutting it in half, because usually you can just cut that parallelogram into two congruent triangles. Okay, so again, a little picture here. If we want to draw, let's go ahead and draw this. Okay, the base is always going to be one of the sides that you can lay flat. So technically, all three of the sides of your triangle can be your base. Okay, really it's just going to come down to you figuring out which one is the most helpful to use. But in this case, the bottom side could be our base here. If that is the case, then the height is always going to be perpendicular to it. So just like we saw in the last one, the height here would have to be perpendicular. Remember, this is what we called one of the altitudes of a triangle. Okay, and this would be the height. Okay, so this is what I'm looking for. And like I said, this works really with any of the sides. So choose one of the sides to be your base. Usually it's going to depend on which one you can find the height for, or the height with. Okay? All right, so those are our two formulas to start here. Let's put this to use. So let's say I'm given this shape and I want to find the area and the perimeter of this parallelogram. So first off, if you need to, make sure you sketch this diagram and pause your video. Okay? But I have this here. Let's start with the area. I want to find the area here. And we know if this is a parallelogram, we just wrote that down, this is going to be the base times the height. And we can use one of these sides as our base. So 17 is the length of this entire side. If it helps as well, if you need to label these to the side, I would recommend doing that. Just keeps things a little bit easier and a little more organized. So let's say the base is going to be 17 yards. Okay, I'll just write that to the side. Okay, notice it's not 9, it's 17 because 9 is just referring to a piece of it. Okay, and then if I want to find the height here, go ahead and write this to the side. I need to find the height to use that equation. Okay, hopefully we can start to see how we would figure that out. We see that this is the height. I have a right triangle here, and specifically, this is one of the ones that we've talked about already. This is a 45, 45, 90 triangle. And in these triangles, we said that the legs are going to be the same length. So for instance, if one of the legs is 9 yards, then the other leg is also going to be 9 yards as well. Okay, and you're going to notice units is a big piece of this chapter as well. So for instance, yards, feet, meters, that's what I mean when I say units. That's what we want to be making sure we're focusing in on and including in all of our answers. Okay, so we have the height here. Since this is 45, 45, 90, height is 9 yards, same as the other leg of that triangle. And so the area is just going to be 17 times 9. Okay, and you can just do this in your calculator or try to do it in your head. Either way, answer here, you're going to end up getting 153. And then like I said, excuse me, we want to make sure we focus on the units. So this is going to be yards, and since it's area, whenever there's area, it's always going to be whatever our unit is squared. Because we just multiplied a yard times a yard, so that would be yards squared. Okay, anytime you have area, make sure you're always taking that unit to the second power. Okay, with perimeter, we don't need to do that. Perimeter, it's just going to be a distance, whatever unit we're using. Okay, so for perimeter here, notice we have two of the sides already technically. Both of those bases would be 17. So I'll go ahead and just label this just in case we are unsure. This is 17 yards. This is a parallelogram, so the opposite sides are congruent. So that's how I know both of them have to be the same. And then if I want to find these two sides here, I can also use things that we've talked about with 45, 45, 90 triangles. Remember, we said with these triangles, we said the two legs are both going to be the same. They would both be A. So in our example, they're both 9. And then that hypotenuse of the triangle is always going to be A squared of 2. So in this case, if A is 9, the hypotenuse is going to be 9 and then times the square root of 2. And like we said, since this is a parallelogram, if one side is 9 root 2, then the other side is also 9 root 2. And I'll go ahead and include yards as well. Okay, so my perimeter here is I just need to add up the 4 sides, which I have all of them now. So I'm going to say the perimeter here is 17 plus 17 plus 9 root 2 plus 9 root 2. Okay, and if you wanted to, you could type all this into your calculator. You can also simplify first. So if it helps, if you want to simplify, you can combine your like terms. Remember, 17 plus 17 we know we can just combine, that's just 34. And then when you have radicals that you're adding together, remember you can only add them together if they have the same base, or in other words, they have the same number under the radical, which they do in this case. So 9 root 2 plus 9 root 2 is going to be 18, and then remember we keep the root the same. Okay, just like 9x plus 9x is 18x, 9 root 2 plus 9 root 2 is 18 root 2. And then like I said, I would just let your calculator do it from here. So if you needed to, you could do it in multiple steps. You could find the square root of 2, which is going to come out to be about 1.4-ish, multiply by 18 to get that value, and then add 34. And your final answer here is going to be somewhat around 59.5. And just like we saw in the last chapter when we were working on trig, I would recommend get in the habit of just rounding off all of the answers that we find to the nearest 10th place, or the nearest decimal. Okay, we're going to see that with all the problems for today. Okay, so this would be here. Perimeter is just going to be yards. It's not going to be yards squared since it's just a distance. And these would be our two answers here. Okay, so notice we're just basically introducing different formulas to use and then practicing them. And then where it's going to come down to us being challenged a little bit is being able to use that in more complicated diagrams. So for example, we just saw this one where we had to use 45, 45, 90 triangles. Okay, we're going to see those same kinds of ideas come up throughout the rest of these problems as well. Okay, all right, another one that we need to talk about. Area of a trapezoid. Okay, finding the area of a trapezoid. And that is going to be this. Okay, area of a trapezoid is going to be 1/2 the height times base 1 plus base 2. Okay, area of a trapezoid is always going to be half the height times base 1 plus base 2. And I want to put those in parentheses. Okay, again, it's a formula, so I'm going to put a box around it, make sure it stands out in my notes. And then if I want a picture with this, okay, we've talked about trapezoids before when we were in our quadrilaterals unit. We said there's just one pair of parallel sides. So for example, in this case, that would be top and bottom. And we said that the one pair of parallel sides that are opposite of each other are going to be what we call the bases of our triangle, or I'm sorry, of our trapezoid. Okay, so these each would be the base, and then just as a reminder, we call the other sides the legs, the sides that are not parallel. But that's not going to come into play here. So What that means for our equation is if I'm looking at this picture, one of the bases is going to be base 1, so it doesn't matter here. This could be base 1, and the other one's going to be base 2. Okay, these are always going to be different lengths, okay, because otherwise it would be, if they were the same length, then it would be a parallelogram. So they're always going to be different lengths, so you just need to choose base 1 plus base 2, and you're always adding them together. So since you're adding them from the beginning, it doesn't matter which one you label as which, okay? And then the only other piece that you need with this here is the height, and again, the height is going to be the same thing. It's going to be this distance, essentially, from one base to the next. Okay, so make sure you don't use either of the legs. You're not using those side lengths. Okay, you're only using the height here, which is most often going to be inside your trapezoid. Okay, there will be a few times where it actually is one of the side lengths, but in general, the height, you're just looking for the distance from one base to the next. Okay? All right, so that's the area of a trapezoid. One other shape that we actually need to introduce here that we did not introduce in our quadrilaterals unit is a kite. Okay, so we didn't go over it. It's not required material that we needed to go over, but we're going to introduce it now because we need to know how to at least find the area of it. Okay, so first off, definition. What is a kite in terms of geometry definitions? Okay, a kite is a quadrilateral with two pairs of adjacent congruent sides. Okay, a kite is a quadrilateral with two pairs of adjacent congruent sides. Okay, so for example here, what this could look like is, let's say we have a quadrilateral, so 4 sides. Let's say these 2 sides are congruent, and then we'll say these 2 sides are congruent as well. Okay, one here, and then 2 and 2. Okay, so this would be an example of a kite. Okay, and you'll notice we just call it a quadrilateral because it's not usually a parallelogram. It usually doesn't have 2 pairs of parallel sides. It usually doesn't have any parallel sides. All I'm worried about is just the distance of the side lengths. Okay, but this would be an example of a kite. Okay, and then area of a kite, and this also applies for a rhombus as well. You might see that on your homework. Okay, area of a kite and a rhombus are both the same. Okay, and the reason for that is because a rhombus is just really a type of kite. Okay, area is this. It's just going to be half the distance, half the length or whatever of diagonal 1 times diagonal 2. Okay, area of a kite, area of a rhombus, whatever you want to call it, is always just going to be 1/2 diagonal 1 times diagonal 2. Okay, you can add the multiplication if you need to. Okay, so for example, we could draw this with a kite or a rhombus, doesn't really matter. Let's draw a rhombus since we've seen that before. Okay, rhombus is a reminder, parallelogram with 4 congruent sides. So again, this would technically be considered a kite because we see 2 pairs of adjacent sides that are congruent. It just so happens in this case, with a rhombus, all 4 of them are the same. Okay, so we have this here. Our formula deals with the diagonals. So right here we could draw one diagonal, call this diagonal 1, this diagonal, diagonal 2. Okay, and to find that, you would multiply them together and then cut it in half. Okay, that is how you find the area of one of these shapes here. Okay, and like I said, that works for a kite as well. And just like we mentioned, since we're multiplying them together, it doesn't matter which one you make diagonal 1, which one you make diagonal 2. Okay, so let's try to put one of those to use here. Like I said, we're not going to have time to go over examples for all of them, but we at least want to make sure we get them written down. So in this case, it says I want to solve for x given that the area of a trapezoid, of this trapezoid here, is 177 centimeters squared. So first off, want to get in the habit, making sure we're looking at the shape. What shape are we looking at? In this case, it's a trapezoid. And as a reminder, our area formula that we just wrote down for that is 1/2 the height times base 1 plus base 2. Okay, so I'm going to go ahead and just write that down first here to make sure we understand which area formula we're going to use. Okay, and now that I have that, I can actually start to plug in some of these values here. Notice we're actually given the area. We're told the area is 177, so I can go ahead and plug that in. I can say 177, and I'm going to put that in parentheses just to remind us that we're plugging it in, or to remind us where that came from. And then we have 1/2. Okay, we actually do have the height here as well. We're given that. That is 13, so I'll just say that's 1/2 times 13. And then in parentheses, I want base 1 times base 2. I am given one of these things here. Let's just say base 1 could be 11. And then base 2 is going to be x here. That is the one that we do not know. That's the one that we are looking for here. Okay? So if I want to solve this equation, I need to try to get x by itself. So first off here, 177 is not going to change. So I can just leave that as is for now. And then if I'm looking for things that I can use or ways that I can simplify this equation, I do see that I have these two things being multiplied together here, 1/2 and 13. So let's just take that. Let's figure out what that is. Half of 13, we could just type it into our calculator if we didn't know, but that's just going to be 6.5. So now I have 177 equals 6.5 times 11 plus x. Okay? And then from here, we have multiple choices. If we're trying to get x by itself, I still can't touch the 11 or the x just yet because they're both in parentheses. So I can do one of two things to deal with that. First thing that I can do that some of you might notice is I can just distribute if I'd like. I can just distribute the 6.5 to both of these values and then solve algebra or solve using algebra like we've done in the past. Okay, one other thing that you can do that's actually a little bit simpler that I'm going to do here is we can actually just divide both sides by 6.5. Okay, this is basically just the opposite of distributing it. I can just divide that 6.5 on both sides so that when I do that, I'm just left with 11 plus x on the right side. Okay, so I'm going to go ahead and do that. And when I do that, these cancel out here when I divide that whole side. On the other side here, I have 177 divided by 6.5. I'm just going to type this into my calculator. And that's going to give me about 27.2-ish. And I'm just going to leave that in my calculator so that I at least have that decimal if I need it. And then that is going to equal 11 plus x. Okay, so again, a little trick that you can use there. You can either distribute if that doesn't make sense, or divide right then. All right, and now we have this here. Last step, all I need to do is just subtract this 11 since I want x by itself. Again, I just kept that number in my calculator, so now I'm just subtracting 11 from it. Either way, this one ends up giving you the same answer whenever you round it off. That's going to be 16.2 if I round it to the nearest tenth. So 16.2 here, and then remember, like I said, we want to make sure we're including units on all of our answers here, so this would be 16.2 centimeters. Okay, it's just a length, so it's just going to be centimeters here. Okay, so that's another way that we'll see these problems or these formulas being used is sometimes you'll actually be given the answer, given the area, and you'll need to use that to find one of your pieces. Okay. All right, last couple formulas that we need to look at, make sure we understand how to use, is the area of a circle and the area of a sector. So first off, area of a circle. Hopefully you've learned this before, but if not, here's what it is. Remember the circumference or the distance around a circle is pi times the diameter. So cherry pie is delicious. And then the other one, the one that you talk about is apple pies R2. Or in other words, area equals pi times r squared. Okay, and as a reminder, the r is representing the radius of the circle, or in other words, the distance from the center to one of the edges. Okay, so we're going to try to draw a circle here. We'll see how this goes. I'm going to focus, see if I can create rough circle, not my worst work. Okay, so we'll draw this here. As a reminder, this is just r. So the radius, distance from the center to the edge. And so you just plug the radius into this equation, you square it, and then multiply it by pi. And that would give you your area. Okay? All right, and then the last piece here, if I want an area of a sector. So let's say we're looking at a circle and we just have a piece of it. You know, you can kind of think of like a piece of a pie or something like that. Okay? If I just want a piece of it, I just want a fraction of the total 360 degrees that are around it. And so the area is going to equal this. It's going to be pi r squared still, and then times x over 360. Okay. Okay, and I'm actually going to draw my picture with this before I explain what x is, because it's going to be a little bit easier to understand. So again, if I want the area of a sector, let's say we draw another circle here. Again, I'm going to try one more time here. See if I can draw a good circle. Let's try one more time. This might take a few attempts, guys. I'm sorry. Okay, that's going to have to do for now. All right, so we have this here. We have this circle. And let's say, like I said, we want a piece of it. So let's say we go maybe here, and then let's go here. Okay, and let's say instead of the whole thing, I just want this piece. I just want this part. Okay, well, we know the distances here. Anytime you go from the center to the edge, that's going to be the radius. So the example right there, that would be the radius. Same thing over here. This would also just be the radius. So I would just need to choose one of those lengths of whatever I'm given. And then x here is always going to be the angle that you're given. So I'm actually going to draw it in this way. Okay, this angle right here, let's say, for instance, in this case, is 101 degrees. Okay, this is going to be x. Okay, so whatever angle measure you're given there, that is going to be x. The reason we divide it by 360 is because if I go around a circle, the entire angle measure when I go all the way around is going to be 360 degrees. So if I just want part of that, if I just want a fraction of that, I just take whatever piece or fraction I'm given. So 101 and divide it by 360. Okay, so I'll write that out here if you need to. Okay, I'll say x is the given angle. Okay, so if you need to write that down, feel free to do so. Okay, but let's try to practice that a little bit and see kind of what I'm talking about here. All right, so last one here, example 3, we want to find the area of the shaded region. So again, if you need to, feel free to pause your video and sketch that circle. Okay, and in this case, I need to find the area of the shaded region, and it's actually the larger piece. I'm actually only given the angle for the unshaded region. So instead of, or there's multiple ways to find the area of this. Here's the method that I'm going to use, is I'm going to find the area of the whole circle, and then I'm going to find the area of this unshaded region and just subtract it from the total. So first off, if I want to find the area of a circle here, okay, I like this method just because it helps us practice both of these equations that we're going to use. Area of a circle we've already said is pi r squared, and we see here r is 11. Okay, if I need to, I can write that to the side. Radius equals 11 inches. Okay, so the area here is going to equal pi times 11 and then squared. Okay, and remember, just as a reminder, your order of operations, you always want to use your exponents first before you multiply. So I want to square my radius always before I multiply by pi. So in this case, that equals pi times 11 squared. So 11 squared is 121. And then from here, this is where your calculator can do the rest of the work. All of your calculators should have pi on it, just 121 times pi. Okay, and you might have to hit the second button to find it. But in any case, that's going to come out to be roughly 380.1. Okay, again, I'll try to keep that decimal in my calculator just in case I need to use it later. Okay, but this is the area of the entire circle. Okay, now what I'm going to do is I'm going to find the area of the unshaded region. Unshaded sector. Okay, and the only difference is I'm going to subtract this at the end. So here our equation is still the same, pi r squared, so pi times 11 squared. And then remember, it's times x over 360. In this case, x, or our angle that we're given, is 65. So I'm going to take whatever I found here and multiply that by 65 over 360. Okay, and the good news is we already know what the first part of this equation comes out to be. We just found it. It's just going to equal 380.1 and then times 65 over 360. Okay, you can round off that decimal now. You can round it off later. It's up to you. If some of your calculators can keep the decimal in there or keep it as kind of an answer, and I can show you how to use that if needed. But in any case, you need to do this. So I would do 65 divided by 360 first. Okay, and that's going to give you about 0.18 or so. And then what I would do is I would multiply that by the answer that we found for the area of the circle, so about 380 points. And I'm going to round it off to a few decimal places to try to get as accurate as possible. So I'm going to multiply by 380.133. Okay, and that's going to give you about 68.6 if I round that off. Okay, so that's roughly a close estimate as to what the area of the unshaded region is. Okay, so we have the area of the entire circle, we have the area of the unshaded region. Now the last step, I'm going to say the area of the shaded region. All I need to do is take my total, which is about 380.1, and subtract what we found for the unshaded region, or the sector, which was 68.6, and then just see what I get here. So 380.1 minus 68.6, and that's going to be about 311.5. Okay, and then make sure as well we're we're putting labels on all of these here. So this was inches squared, this was inches squared, and this was inches squared as well, since all of these are areas. Okay, and this would be my final answer. It would be about 311.5 inches squared. Okay, it might not be exact, but it might be off by a few decimal places because of the way our calculators work. But overall, this would be your final answer here. Okay, so these are the formulas that you need to be able to use. I know I've kind of run long with this video, but there's a lot to cover. If you guys have any questions, as always, feel free to let me know.